Hello there, and welcome to 100 Facts Before Sleep. Tonight, we drift beyond our galaxy and into the great cosmic ocean, the universe. It is a canvas of four-dimensional space and time, stretching across an invisible expanse of billions of light years. Every distant galaxy we observe, every ripple of gravity we detect, and every moment of light we measure carries the ancient echo of its beginning. It is both our ultimate origin and our endless horizon. If you enjoy these quiet journeys, I invite you to subscribe or share a thought below. For now, just breathe. Let your eyes grow heavy, and let the quiet wonder of the entire universe cradle your thoughts. Let's begin. Fact 1. The most astonishing truth about the universe is that it is overwhelmingly composed of things we cannot see, touch, or detect directly. Ordinary matter, including all stars, galaxies, and life, makes up less than 5% of the total mass energy content of the cosmos. The majestic galaxies and the brilliant stars we observe are merely the luminous minority of this vast expanse, a gentle, visible froth upon a deep, dark sea of the unknown. To try and conceptualize this proportion, imagine all of human history and knowledge representing only a tiny fraction of a single penny. The largest portion, about 27%, is attributed to dark matter, an unseen substance that interacts only through its gravitational pull. The remainder, a colossal 68%, is the mysterious dark energy, an even more baffling entity that is actively accelerating the universe's expansion. This quiet realization means that the universe is governed and dominated by forces and materials that remain profoundly mysterious, reminding us that our exploration of the cosmos has truly just begun. Fact 2. The current best estimate for the age of the universe is approximately 13.8 billion years. This incredible span of time is not a random guess, but a precise calculation derived from the rate at which the universe is expanding and from measuring the ages of the oldest known stars and cosmic structures. Scientists use the faint, pervasive afterglow of the Big Bang, known as the cosmic microwave background, CMB, radiation, as a primary timepiece. This radiation, which is the heat left over from the universe's fiery beginning, carries the imprint of the cosmos when it was only about 380,000 years old. By observing the subtle fluctuations in this ancient light and applying the laws of physics, we can quietly rewind the clock, confirming the monumental span of time that separates us from the moment when both space and time itself began to exist. This vast age ensures that there has been ample time for stars to form, explode, and recycle their materials, eventually leading to the complex atoms that compose our planet and ourselves. Fact 3. The sheer incomprehensible size of the observable universe is a figure that quietly stretches the limits of our minds. Due to the constant expansion of space since the Big Bang, the edge of what we can currently see, the cosmic horizon, lies approximately 46.5 billion light-years away in every direction. This means the diameter of the observable universe is roughly 93 billion light-years across. This distance is far greater than the universe's age suggests, because space itself has been expanding while the light has been traveling towards us. Light that was emitted 13.8 billion years ago has traveled that length, but the region of space that emitted it is now much further away due to this expansion. This vast sphere, with Earth quietly situated at its center, represents the absolute boundary of our current perception, a limit imposed not by technology, but by the finite speed of light and the relentless march of cosmic time. Fact 4. The universe is not a static place. but is in a state of continuous, accelerated expansion, a phenomenon driven by the enigmatic force known as dark energy. Unlike gravity, which pulls things together, dark energy exhibits repulsive gravity, subtly pushing the fabric of spacetime apart. The quiet, profound implications of this force mean that the expansion is not slowing down, as one might expect from the gravitational pull of all the matter, but is actually speeding up. This gradual acceleration is the dominant factor in the ultimate fate of the cosmos, ensuring that distant galaxies will eventually recede from us at speeds faster than the speed of light, quietly disappearing beyond our cosmic horizon. Dark energy, which accounts for a colossal 68.3% of the universe's mass energy content, remains a staggering mystery, its nature and origin being one of the greatest unsolved puzzles in all of science. Fact 5. The foundation of the entire cosmos rests on a surprisingly small amount of visible material. All the stars, planets, asteroids, comets, and living things, the ordinary matter that we can see, feel, and detect, make up a mere 4.9% of the total composition of the universe. The simplest atomic element, hydrogen, which is composed of only a single proton and electron, is the most abundant form of this ordinary matter, existing as vast, diffuse clouds between the galaxies. This small percentage of matter is responsible for all the luminous beauty we observe, from the faint flickers of distant quasars to the brilliant glow of the Milky Way, yet it is utterly overwhelmed by the dark, invisible components that govern the structure and dynamics of the universe. This profound imbalance quietly reminds us that our perception of the cosmos is strongly skewed toward the tiny fraction of its content that emits light. Fact 6. The other great invisible constituent of the universe is dark matter, which comprises roughly 26.8% of the cosmic mass energy pie. We know this mysterious substance exists not because we can see it, but because of its powerful, yet quiet, gravitational effects on visible matter. Dark matter acts as an invisible gravitational tug, preventing stars in the outer regions of galaxies from being flung out into space and holding together massive structures like galaxy clusters. Its gravity warps the fabric of spacetime, creating spectacular effects like gravitational lensing, which allows us to observe magnified and distorted images of background galaxies. Though its identity remains unknown, with candidates ranging from hypothetical subatomic particles to primordial black holes, its quiet, pervasive presence is essential for the formation and stability of all large-scale structures, including our own Milky Way galaxy. Fact 7. The universe is not a uniform soup of randomly distributed galaxies. It is structured in a vast, intricate, and quiet framework known as the cosmic web. This colossal structure consists of walls, filaments, and nodes, which are the densest regions where galaxies cluster together, and immense, sprawling voids, which are largely empty of galaxies. This quiet, web-like geometry is the largest known structure in the universe, a magnificent pattern that traces the initial density fluctuations left over from the Big Bang. Galaxies are typically found clustered along the long, stretched filaments of this web, moving toward the dense nodes that host massive galaxy clusters. This quiet, non-random distribution of matter is a direct consequence of gravity, amplifying the tiniest primordial fluctuations over billions of years, slowly shaping the cosmos into this colossal, beautiful network. Fact 8. The universe's fundamental architecture is characterized as four-dimensional space-time. This is a concept where the three dimensions of space, length, width, and height, are fundamentally intertwined with the single dimension of time. Proposed by Albert Einstein, this elegant model means that time is not an absolute constant flow, but is relative and can be affected by gravity and velocity. The most massive objects, like black holes, warp this fabric of spacetime, and gravity itself is merely the effect of objects following the straightest possible path along this curvature. This quiet, underlying geometry ensures that a massive star not only has a physical presence in space, but also dictates the flow of time and the curvature of space around it, making the universe a dynamic, flexible, and unified entity. Fact 9. The average temperature of the entire universe today is a chilling 2.72548 Kelvin, which is only about -270.4 degrees Celsius. This quiet, cold temperature is a direct measure of the cosmic microwave background, CMB, radiation. The residual heat left over from the Big Bang fireball. As the universe expanded, the energy of this primordial radiation was stretched, or redshifted, to longer, lower energy wavelengths, causing the temperature to drop over billions of years. The fact that this temperature is essentially the same everywhere we look, regardless of direction, is a profound piece of evidence supporting the standard cosmological model, indicating that the universe was once in a remarkably uniform, hot, and dense state. This pervasive, quiet chill is the universe's ultimate ambient temperature, the final, faint whisper of its fiery youth. Fact 10. The sheer number of stars in the observable universe is a figure that requires deep, quiet contemplation. Astronomers estimate that the observable cosmos contains an astonishing number of stars, perhaps as high as 1 septillion, or a 1 followed by 24 zeros, $10 circumflex, $24 stars. This immense population is distributed among an estimated 2 trillion galaxies. To try and grasp this quiet enormity, consider that the number of stars in the cosmos far exceeds all the grains of beach sand on planet Earth. This staggering abundance of stellar systems confirms that the cosmos is a luminous, crowded place, with every one of those septillion stars representing a potential solar system, a quiet new sun, and a vast, unknown frontier for planetary existence. Facts 11 to 20. Galaxies, quasars, and cosmic evolution. Long form. Fact 11. At the heart of nearly every large galaxy, including our own Milky Way, there quietly resides a supermassive black hole. These colossal entities range in mass from millions to tens of billions of times the mass of the Sun, dominating the gravitational pull in the central region. The correlation between the mass of the black hole and the total mass of the galaxy's central bulge suggests a deep, interconnected history, though the mechanism remains one of the biggest unsolved questions in astrophysics. Did the black holes form first, acting as seeds for the surrounding galaxies, or did the newborn galaxies somehow spawn them? While most of these giants, like the one in the Milky Way, are currently dormant, their immense, quiet presence is a fundamental feature of galactic structure, a powerful, dark anchor at the core of every cosmic island. Fact 12. The most distant and powerful objects we can observe are the quasars, which are essentially the luminous, energetic cores of young galaxies. These brilliant beacons outshine their entire host galaxy by orders of magnitude, often pumping out 100 times more light than a normal galaxy. This incredible energy does not come from stars, but from the colossal supermassive black holes at their center, which are actively and violently consuming vast amounts of matter. As matter swirls down toward the black hole, it is heated to incandescence, creating a dazzling high-energy accretion disk. Observing these quiet, brilliant objects allows us to peer back in time to the earliest epochs of the universe, providing a profound glimpse into how galaxies and their central black holes grew when the cosmos was still in its energetic youth. Fact 13. The universe began approximately 13.8 billion years ago in a single quiet cataclysmic event known as the Big Bang. Before this moment, neither time, space, nor matter, as we know it, existed. The Big Bang was not an explosion that occurred in space, but rather the expansion of space itself from an infinitely hot, dense, singular point. As the universe expanded, it cooled, allowing fundamental particles to form, then atoms, and eventually stars and galaxies. This profound beginning is the ultimate cosmic origin story, providing a precise timeline for all the events that have quietly unfolded since, from the formation of the first stars to the eventual fate of the cosmos. Fact 14. The observable universe is not the entire universe. It is merely a spherical region of the entire cosmos that is currently within our view. This boundary is defined by the distance light has had time to travel to Earth since the Big Bang. Because the universe may be infinite in extent, there are parts of the cosmos that are simply too far away for their light to have reached us in the 13.8 billion years of cosmic history. Therefore, our observable region is like a bubble with Earth at its center, and this bubble is constantly, quietly expanding by 1 light year every Earth year as more distant light finally reaches us. The entire universe may be vast, unbounded, and much larger than this finite sphere of observation. Fact 15. The very first luminous objects in the cosmos, the earliest stars, are estimated to have formed only about 200 million years after the Big Bang. These stars, likely massive and short-lived, were designated population 3 stars, and they were composed almost entirely of the primordial elements created in the Big Bang, hydrogen and helium. Their lives were brief and explosive, and their deaths were crucial, as they were the first stellar furnaces to forge the heavier elements, such as carbon, oxygen, and iron, which would eventually seed the rest of the universe and make the formation of rocky planets and life possible. Their quiet, explosive sacrifice laid the entire chemical foundation for the universe as we know it today. Fact 16. One of the greatest paradoxes of the universe is that the vast, empty space between the galaxies is not truly empty. It is filled with a thin, uniform, and pervasive electromagnetic radiation known as the cosmic microwave background, CMB. This ancient light is the residual heat left over from the Big Bang fireball, when the universe was only 380,000 years old, and the radiation first broke free from matter. The quiet, faint fluctuations in the temperature of the CMB, which are only tiny fractions of a degree, represent the original density fluctuations in the early universe, which acted as the quiet seeds that eventually grew, through gravity, into the colossal galaxies and structures we observe today. Fact 17. The universe is so incredibly huge that the number of galaxies within the observable region alone is estimated to be around 2 trillion. These galaxies are not just isolated stars. Each one is a vast, self-contained island of stars, gas, and dark matter, containing anywhere from millions to hundreds of billions of suns. This quiet multitude of galaxies means that the cosmos is a luminous, crowded place, with each galaxy serving as a unique laboratory of stellar birth, evolution, and death. The sheer scale of this galactic population confirms that our own Milky Way, though immense to us, is merely one among a countless, quiet sea of similar, colossal, stellar structures. Fact 18. The fate of a massive star is often a quiet, cataclysmic event known as a supernova. These are immense stellar explosions that occur when a massive star exhausts its nuclear fuel and its core collapses under its own immense gravity. A single supernova can briefly outshine an entire galaxy, scattering the heavy elements forged in the star's core throughout the cosmos. These explosions are vital for the universe, as they are the only natural way to create and distribute the heavier elements, such as gold, platinum, and uranium, ensuring that future generations of stars and planets can form with the complex chemical building blocks necessary for life. A supernova is a profound act of stellar self-sacrifice, quietly fueling the complexity of the future. Fact 19. The universe exhibits a remarkable, large-scale flat geometry. This means that over immense distances, the geometry of space behaves according to the simple rules of Euclidean geometry, much like a flat sheet of paper. This quiet geometric flatness has profound implications for the ultimate fate and structure of the universe, and strongly suggests that, during the first fraction of a second after the Big Bang, the universe underwent an incredibly rapid burst of expansion known as inflation. This burst stretched the fabric of space to a size so vast that any initial curvature became virtually unnoticeable, leaving the cosmos with its observed, uniform, and elegant flat geometry. Fact 20. The fundamental laws of the universe are unified under the elegant principle of spacetime, proposed by Einstein. This concept integrates the three dimensions of space and the single dimension of time into a single, seamless, four-dimensional fabric. This fabric is not rigid. It is dynamic and pliable, warped and curved by the presence of massive objects. This quiet curvature is what we perceive as gravity. This profound geometric unity ensures that every motion, every event, and every passage of time in the universe is fundamentally interconnected, making space and time merely two aspects of the same quiet, cosmic structure. Facts is Ishibir, Samship, time, gravity, and quantum mysteries. Long-form fact 21. One of the most mind-bending consequences of Einstein's theory of general relativity is time dilation, the quiet realization that time does not pass at the same rate for everyone. The flow of time is relative and is profoundly affected by both gravity and velocity. The stronger the gravitational field, such as near a black hole, the slower time moves. Similarly, the faster you move through space, the slower time moves relative to a stationary observer. This means that a clock on a fast-moving satellite or near a massive star will quietly tick at a slightly different rate than a clock on Earth. This subtle, pervasive effect proves that time is a flexible, dynamic dimension, intricately woven into the fabric of space-time. Fact 22. Black holes are not cosmic vacuum cleaners that actively suck in matter from afar. Their gravitational effects are the same as any other object of equal mass from a distance. If our sun were magically replaced with a black hole of the exact same mass, the Earth and all the other planets would simply continue to orbit the black hole in precisely the same paths they follow now. A black hole only becomes the ultimate gravitational trap when matter crosses its invisible boundary, the event horizon, where the warping of space-time becomes so extreme that escape is impossible even for light. This quiet truth reminds us that gravity is a passive rather than an aggressive force. Fact 23. The universe is filled with colossal, unseen structures known as filaments that quietly stretch for hundreds of millions of light years. These are the densest components of the cosmic web, giant, rope-like strings of dark matter and galaxies that connect the massive clusters and superclusters of galaxies. These filaments act as cosmic highways, guiding the slow gravitational movement of entire galaxies toward the densest nodes of the web. The existence of these vast, quiet structures demonstrates that matter in the universe is not randomly spread, but is organized into a massive, elegant, and persistent network, shaped by the gentle, long-range pull of gravity over billions of years. Fact 24. The universe is permeated by gravitational waves, which are invisible, powerful ripples in the fabric of spacetime itself. These quiet, subtle waves are generated by the immense, chaotic acceleration of massive objects, such as two merging black holes or colliding neutron stars. When they pass through a region of space, they gently stretch and squeeze the distances between objects, an effect so subtle it can only be detected by incredibly sensitive instruments, like the LIGO observatory. The detection of these waves confirmed a key prediction of Einstein's general relativity and opened a profoundly new way to observe the universe, allowing us to quietly listen to the most violent and energetic events in the cosmos. Fact 25. One of the most common and quiet components of the universe is atomic hydrogen gas, which exists as vast, diffuse clouds between the stars and galaxies. In its neutral form, this gas is invisible in the optical spectrum. However, its atoms emit a faint, incredibly specific radio signal at a wavelength of 21 centimeters. This quiet, persistent signal, detected by radio telescopes, is the key to mapping the structure of galaxies, including our own Milky Way, as the radio waves can pass unhindered through the dense dust clouds that block visible light. This simple, quiet signal is the most fundamental sound of the universe's structure. Fact 26. The oldest and most elusive stars in the cosmos, the theoretical population 3 stars, were likely colossal and short-lived, with masses up to 100 times that of the Sunday. These stars, born from the pure, primordial hydrogen and helium of the Big Bang, were the universe's first light sources, quietly emerging in the cosmic dark age, only about 200 million years after the Big Bang. Because they were so massive, their lives were brief and ended in colossal supernovae, which were essential for creating the first generation of heavy elements, forging the very chemical foundation of all future stars and planets. Fact 27. The universe contains an immense, quiet, and ancient body of water. Scientists discovered a vast reservoir of water vapor located around a distant, powerful quasar, approximately 12 billion light-years away. This reservoir is the largest and oldest body of water in the cosmos, holding an amount of water equivalent to 140 trillion times all the water in Earth's oceans. The water is believed to have been created by the waves of energy from the quasar, which gently knocked hydrogen and oxygen atoms together in the gas cloud. This quiet, vast ocean of primordial water, existing in the earliest times of the universe, proves that the basic ingredients for life, hydrogen and oxygen, were present and abundant, almost from the very beginning. Fact 28. The fundamental unit of distance in cosmology is the light year, defined as the distance light travels in one Earth year. Given that light moves at a constant speed of approximately 300,000 kilometers per second, 1 light year is roughly 9.46 trillion kilometers. This quiet, precise measurement serves as a necessary scale for comprehending the immense distances between stars and galaxies. When we observe an object that is 10 million light-years away, we are quietly looking 10 million years into the past, as the light we are seeing was emitted that long ago. The universe is thus an immense, quiet, and constantly revealing time machine. Fact 29. The vastness of the universe implies an immense and staggering number of exoplanets, planets, orbiting stars other than the Sun. Current estimates suggest that the observable universe may contain as many as 100 billion trillion $10 circumflex $24 stars. Given that most stars are believed to host at least one planet, the number of planets in the cosmos is simply too large to quietly comprehend. This quiet, scientific consensus confirms that planets are the rule, not the exception, in the universe, suggesting an unimaginably vast, unknown population of rocky, icy, and gaseous worlds waiting to be discovered, each a potential habitat in the cosmic expanse. Fact 30. The universe began in an incredibly uniform, hot, and dense state, yet the subtle variations that led to all the complexity we see are the tiny, quiet fluctuations in the cosmic microwave background, CMB. These minute temperature and density differences, which correspond to spatial scales of millions of light-years across, are the gravitational seeds that eventually evolved into the vast walls, filaments, and clusters of the cosmic web. The most dominant of these structures are incredibly large, such as the enormous grouping of galaxies dubbed the Great Wall, which stretches across millions of light-years. The quiet, large-scale homogeneity of the universe, born from these tiny initial seeds, is a profound testament to the power of gravity over cosmic time. Facts 31 to 40. The solar system and our sun's role. Long-form fact 31. Our sun is a majestic, approximately 4.5 billion-year-old yellow dwarf star, a giant, hot, glowing ball of plasma that sits quietly at the center of our solar system. The sun's sheer size is immense. It is about 100 times wider than Earth. Its gravity is the quiet, ultimate anchor of our entire system, holding everything from the smallest bits of space debris to the largest planets, asteroids, and comets in their precise orbits around it. This continuous, powerful gravitational pull ensures the long-term stability and rhythm of our home system, making it the most dominant and essential object in our quiet neighborhood. Fact 32. The sun contains nearly all of the mass of the entire solar system. The mass of our star is so immense that it would take more than 330,000 Earths to match the sun's mass, and roughly 1.3 million Earths to fill the sun's volume. The gravitational power derived from this colossal mass is what generates the immense outward pressure that keeps the sun from collapsing in on itself, maintaining a delicate, quiet balance with the inward crush of its own gravity. This profound mass dominance ensures that the sun's will is law in our solar neighborhood, quietly dictating the motions and positions of every single orbiting body. Fact 33. Despite its overwhelming dominance in our local system, the sun is only an average star in terms of its size when compared to the vast stellar population of the universe. Many solar systems contain more than one star, and stars up to 100 times larger than the sun have been found across the cosmos. This quiet realization places our sun squarely in the middle of the cosmic stellar hierarchy, a reminder that while it is essential for our survival, it is merely one of the trillions of stars that populate the universe, a beautiful and quiet example of a common, life-giving star. Fact 34. The sun's surface, known as the photosphere, is not a solid boundary. It is the part of the superhot, electrically charged gas, or plasma, that we perceive as the star's quiet surface from Earth. Because the sun is not solid, it rotates at different speeds at different parts of its body. At its equator, the sun completes one rotation in about 25 Earth days, but at its poles, one rotation takes longer, about 36 Earth days. This quiet, differential rotation is a key feature of its magnetic fields and activity, a subtle, beautiful dance of plasma that continually drives the powerful forces that affect our solar system. Fact 35. The time it takes for our solar system to complete one full revolution around the center of the Milky Way is approximately 230 million years. This vast period is known as a galactic year. To quietly put this immense timescale into perspective, the last time the Sun was in its current position in the galaxy, dinosaurs were just beginning to walk the Earth, and the continents were only beginning to drift apart. The entire history of modern humans, which spans only about 0.001 galactic years, is a mere, fleeting moment in the long, quiet, rhythmic journey of our solar system through the cosmic expanse. Fact 36. The space between the stars and galaxies is generally very empty, but it is not a perfect vacuum. It is filled with trace amounts of matter, gas, and energy. Even in the quietest regions far from any star or planet, there are still scattered particles of dust and a few hydrogen atoms per cubic centimeter. This quiet, diffuse medium is also filled with magnetic fields, faint radiation, like light and heat, and high-energy particles known as cosmic rays. This continuous, subtle presence of matter and energy, though incredibly thin, ensures that every corner of the universe is fundamentally interconnected. Fact 37. The universe is filled with a vast number of planets that are not gravitationally bound to any star, known as rogue planets. These quiet, sunless worlds wander the interstellar medium in cold, solitary orbits, having been violently ejected from their birth solar systems during the chaotic early stages of planet formation. While they are incredibly difficult to detect, their sheer numbers are estimated to be immense, potentially outnumbering the stars in the galaxy. These quiet, dark worlds offer a unique perspective on planetary existence, suggesting that life, if it were to evolve there, would have to draw its energy from geothermal heat or internal planetary processes, rather than the light of a star. Fact 38. The immense gravity of massive galaxy clusters can subtly bend and distort the fabric of spacetime itself, creating a profound effect known as gravitational lensing. This warping acts like a giant, natural magnifying glass in space, stretching and magnifying the light from galaxies that are located far behind the cluster. This quiet, pervasive effect is one of the most powerful tools astronomers have, as it allows them to see objects that would otherwise be too distant or too faint to detect, and it provides definitive proof of the immense, unseen mass of the dark matter that dominates the cluster's gravitational field. Fact 39. The earliest visible features in the universe were the proto-galaxies that quietly formed the earliest stars and structures. Scientists estimate that the earliest stars formed some 200 million years after the Big Bang. These first galaxies were likely much smaller and more chaotic than the grand spirals we see today, forming through the slow, gravitational clumping of the primordial hydrogen and helium gas. Their collective light quietly ended the cosmic dark ages, the epoch that followed the Big Bang when the universe had cooled but had not yet formed any stars, and their luminous existence marked the beginning of structure formation in the cosmos. Fact 40. The ultimate fate of the universe is largely determined by the mysterious, accelerating force of dark energy. If the rate of expansion continues to accelerate, the cosmos may face a big freeze or heat death, where the universe expands so rapidly that all galaxies quietly recede from one another, all stars burn out, and the universe becomes a cold, dark, and empty expanse. Conversely, if dark energy's repulsive power were to increase rapidly, it could lead to a big rip, where all structures, from galaxies to atoms, are quietly torn apart by the relentless expansion of space-time itself. This profound, quiet destiny is dictated by a force we still do not understand. Facts 41 to 50. Black holes, space-time, and cosmic odors. Long form. Fact 41. Black holes are not truly wormholes. They do not provide shortcuts between different points in space or act as portals to other dimensions or universes. While wormholes' theoretical Einstein-Rosen bridges are a mathematical possibility within general relativity, they require the existence of exotic matter with negative energy density to remain stable, a substance that has not been observed in the universe. Black holes are dense, collapsed concentrations of matter, and anything that crosses the event horizon is destined for the singularity, not another universe. This quiet distinction keeps the most exciting concepts of science firmly in the realm of theory for now. Fact 42. The closest known black hole to Earth, called Gaia BH1, is an incredibly quiet neighbor, residing about 1,500 light-years away. This stellar mass black hole is about 10 times the mass of the Sun, but it is entirely dormant and does not actively feed on a companion star. Its existence was quietly inferred by observing the subtle wobble of its companion star as it orbited the unseen gravitational anchor. The discovery of such a close, quiet, and isolated black hole suggests that our own Milky Way galaxy likely contains billions of other, similarly quiet stellar mass black holes, silently drifting through the cosmic expanse. Fact 43. The universe's largest and most massive black hole observed, TON 618, is a true cosmic behemoth, tipping the scales at an astonishing 66 billion times the mass of the Sunday. This ultra-massive black hole resides at the center of a distant quasar, violently consuming matter and generating an incredible amount of light. Its existence challenges the current models of how rapidly black holes can form and grow in the early universe, as it achieved this colossal size in the relatively short time since the Big Bang. This quiet, profound discovery pushes the limits of our understanding of black hole evolution and the dynamics of early galactic growth. Fact 44. The universe has an end of greatness, which is a quiet structural boundary in the cosmos where the largest coherent structures cease to exist. On a scale of about 300 million light-years, the distribution of matter becomes essentially homogeneous and isotropic, meaning it looks the same in every direction. Below this scale, galaxies cluster into the immense walls, filaments, and voids of the cosmic web. Beyond this scale, the web dissolves into a quiet, statistically uniform sea of galaxies, confirming that there is a definitive, quiet limit to the size of the largest bound structures in the universe. Fact 45. One of the most fascinating quiet sensory facts about the cosmos is that the giant cloud of gas and dust at the center of the Milky Way galaxy has a distinct, surprising smell of rum and raspberries. This pleasant odor is due to the presence of a chemical called ethyl formate, which is also responsible for giving raspberries their flavor and contributing to the scent of rum. Furthermore, another nearby cloud contains vast amounts of ethyl alcohol, or ethanol, enough to supply every person on Earth with millions of pints of low-proof alcoholic beverage per day for 1 billion years. This quiet chemical complexity confirms that the building blocks of flavor and fragrance are abundant even in the deepest, quietest parts of space. Fact 46. The universe is filled with highly energetic, electrically charged particles known as cosmic rays. These quiet, powerful particles, mostly protons and atomic nuclei, are accelerated to speeds approaching the speed of light by the most violent events in the cosmos, such as supernovae and active galactic nuclei. When these particles strike Earth's atmosphere, they shatter into showers of secondary particles, bombarding our planet constantly. Their energy is so immense that their origin remains one of the deepest quiet mysteries in science, as they carry no charge to betray their source, quietly traversing the vast, magnetic fields of the galaxy. Fact 47. The existence of extra dimensions is a quiet, foundational concept in advanced theories like string theory. While we experience 3 dimensions of space and 1 of time, string theory proposes that there may be several additional spatial dimensions that are curled up and too small for us to detect. If these dimensions exist, they would quietly influence gravity and the behavior of subatomic particles, potentially providing the long-sought-after unified theory of everything that elegantly merges general relativity with quantum mechanics. This quiet possibility suggests that the fabric of reality is far more complex and multi-layered than we currently perceive. Fact 48. The holographic principle is one of the most mind-bending theories about the nature of the universe, emerging from the study of black holes and information. This quiet principle suggests that all the information contained within a 3-dimensional volume of space can be fully encoded on its 2-dimensional boundary surface. This leads to the profound, quiet idea that our entire 3-dimensional reality may actually be a projection of information that resides on a distant, 2-dimensional cosmic horizon. Though highly theoretical, this concept dramatically challenges our conventional understanding of space, information, and the quiet reality we inhabit. Fact 49. The ultimate fate of the Sun will be a long, quiet metamorphosis, eventually transforming it into a white dwarf. In several billion years, the Sun will exhaust the hydrogen fuel in its core, causing it to swell into a colossal red giant, expanding so far that it will swallow Mercury and Venus, and likely fill Earth's sky. After this phase, the Sun's outer layers will gently drift away, leaving behind a small, dense, and incredibly hot core that will slowly cool and dim over trillions of years. This quiet, inevitable decay is the common end for all sun-like stars in the universe. Fact 50. The universe is quietly governed by the cosmic principle, which states that the universe is isotropic and homogeneous when viewed on its largest scales. Homogeneous means that matter is distributed uniformly throughout space, and isotropic means that the universe looks the same in every direction. This quiet uniformity, despite the complex structures we see on smaller scales, is a crucial assumption of modern cosmology. It is a fundamental truth that allows us to apply the same physical laws and models to study the entire cosmos, confirming that the universe's ultimate structure is one of vast, quiet, and consistent regularity. Facts 51 to 60. The early universe and cosmic background. Long-form fact 51. The earliest era of the universe, before the formation of stars, is often referred to as the Cosmic Dark Ages. This quiet epoch began after the cosmic microwave background, CMB, radiation was released, roughly 380,000 years after the Big Bang, and lasted until the formation of the first stars, about 200 million years later. During this time, the universe was filled with cold, neutral hydrogen and helium gas, and there were no luminous objects to emit light. The cosmos was dark, quiet, and slowly expanding, patiently waiting for the gravitational clumping of matter to trigger the luminous birth of the first stars and galaxies. Fact 52. The quiet ripples in the cosmic microwave background, CMB, are often referred to as the seeds of the galaxies. These tiny temperature fluctuations, only a few parts per million, correspond to regions of slightly different density in the early universe. The slightly denser regions had a stronger gravitational pull, which quietly attracted more matter over billions of years, eventually collapsing into the massive galaxy clusters, filaments, and walls that make up the cosmic web today. This subtle, quiet irregularity in the primordial soup is the ultimate origin of all the large-scale structure we observe in the cosmos. Fact 53. The universe is currently accelerating in its expansion, a phenomenon driven by dark energy. This quiet acceleration means that as time passes, more and more distant galaxies will recede from us at speeds faster than the speed of light. This does not violate Einstein's theory of relativity, as it is space itself that is expanding between the galaxies, not the objects moving through space. The eventual consequence is that these distant galaxies will quietly vanish from our observable horizon, and the night sky of the far future will become increasingly empty and dark, leaving us visually isolated in our local cluster. Fact 54. The universe's expansion is measured using Hubble's law, which states that the recessional velocity of a galaxy is proportional to its distance from us. This means that the farther a galaxy is, the faster it appears to be moving away. This quiet, linear relationship is a direct consequence of the continuous expansion of spacetime. Hubble's observation of this quiet, systematic movement was the first compelling evidence for a universe that had a beginning and was not static, leading directly to the Big Bang theory. Fact 55. All of the other 7 planets in our solar system, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, could comfortably fit into the space between the Earth and the Moon. The average distance between the Earth and the Moon is approximately 400,000 kilometers, or 250,000 miles. This quiet realization profoundly demonstrates the vast amount of empty space that exists even within our own local gravitational environment, reminding us that even the most massive objects are tiny points separated by immense, quiet distances. Fact 56. The oldest light in the universe, the cosmic microwave background, CMB, radiation, is technically only about 380,000 years younger than the universe itself. Before this time, the universe was a dense, hot plasma where electrons and protons were not yet bound into atoms. Light particles, or photons, were constantly scattered by the free electrons, making the universe opaque, like a thick fog. When the universe cooled enough for neutral atoms to form, the photons were suddenly free to travel, and this quiet moment of decoupling is the light we now see as the CMB. Fact 57. The quiet concept of gravitational lensing is one of the most powerful tools in cosmology. Massive objects, such as galaxy clusters, bend and distort the light from more distant objects behind them, acting as a powerful natural magnifying glass. This quiet distortion allows astronomers to study galaxies that are otherwise too far away to see, and it is a key method used to map the distribution of invisible dark matter by observing how much the background light is bent. Fact 58. The very first luminous structures to appear after the cosmic dark ages are responsible for the epoch of reionization, one of the most profound transformations in cosmic history. The intense ultraviolet radiation emitted by these first stars and quasars stripped the electrons from the neutral hydrogen gas that filled the universe, quietly converting it back into an ionized plasma. This quiet event made the universe transparent to light, allowing the photons to travel freely, and it is the direct reason why we can see distant galaxies today. Fact 59. The quiet fate of our planet, Earth, is intrinsically tied to the fate of the Sunday. In several billion years, as the sun swells into a red giant, it will expand dramatically, eventually swallowing Mercury and Venus. and filling the Earth's sky. While the exact fate of the Earth is difficult to predict, it will either be consumed by the expanding sun or be rendered completely uninhabitable by the intense heat and radiation, a quiet, profound end to our planetary home. Fact 60. The universe is filled with colossal, almost spherical structures known as voids. These are the quietest, most empty regions of the cosmic web, spanning hundreds of millions of light-years and containing very few, if any, galaxies. These immense, quiet stretches of nothingness were formed by the same initial density fluctuations as the filaments and clusters, but in the regions where the initial density was slightly lower than average, the quiet push of gravity ensured that matter moved away from them over cosmic time. Facts 61 to 70. Extreme objects in cosmic chemistry. Long form. Fact 61. The most distant black hole detected to date is located at the center of a galaxy called QSOJ 313-11806, and it is approximately 13 billion light-years away. The light from this quiet, distant black hole was emitted when the universe was incredibly young, making it a crucial tool for studying the rapid growth and evolution of supermassive black holes in the early cosmos. Its mere existence so early in time suggests that black hole formation was an extremely rapid and efficient process in the universe's youth. Fact 62. The quiet term spaghettification refers to the horrific process of what happens when any object, such as a star or a human, falls into a black hole. The immense tidal forces the difference in gravitational pull between the side of the object closer to the black hole and the side farther away become so extreme that they stretch and tear the object apart into a long, thin stream of individual atoms, resembling a strand of spaghetti. This quiet, inevitable destruction is the ultimate expression of gravity's differential force. Fact 63. The universe is an immense, quiet, and slow-moving time machine. The light from a star that is just 31.7 light-years away takes exactly 1 billion seconds to reach Earth. This quiet, precise connection between space and time is a direct consequence of the finite speed of light. Every moment of light we capture from any star is a silent, ancient message, confirming that we are constantly looking into the past, with the depth of the past dictated by the vast distance of the object. Fact 64. The simplest atomic element, hydrogen, which is the most abundant element in the entire universe, is composed of a single proton and an electron. The fusion of hydrogen atoms into helium is the quiet, essential process that powers our sun and nearly all other stars in the cosmos. This fundamental, quiet conversion of mass into energy is the engine that drives the luminous life of galaxies, ensuring that the universe is constantly filled with light and heat. Fact 65. Neutron stars are the incredibly dense remnants of massive stars that were not quite massive enough to collapse into a black hole. These quiet, tiny objects are so dense that a piece of their material the size of a sugar cube would weigh billions of tons. They are often observed to spin hundreds of times each second, a rapid rotation that creates immense magnetic fields and generates powerful radio pulses, leading to their discovery as pulsars. Fact 66. The quiet fate of the universe is still debated, but the theories include the cyclic universe model. This theory proposes that the universe does not end in a big freeze or a big rip, but instead goes through endless cycles of expansion and contraction. In this model, the current expansion would eventually slow, reverse into a big crunch, and then quietly rebound into a new big bang, ensuring that the cosmos is constantly reborn in a perpetual, Rhythmic cycle of creation and destruction. Fact 67. The universe is quietly governed by the laws of thermodynamics, including the law that dictates that entropy must always increase. Entropy is a quiet measure of the universe's disorder, and its continuous increase is the fundamental reason why time appears to flow in only one direction, from the past to the future. The quiet, inexorable rise of entropy is the underlying force driving the universe toward its ultimate quiet state of maximum disorder, often referred to as heat death. Fact 68. The quiet phenomenon of quantum entanglement suggests that two subatomic particles can become so intimately linked that they share the same existence, regardless of the distance separating them. If one particle's property is quietly measured, the property of the other particle is instantaneously determined, even if they are billions of light years apart. This quiet, spooky action at a distance is one of the deepest and most profound mysteries of quantum mechanics, hinting at a fundamental, non-local connection that underlies the entire structure of the universe. Fact 69. The existence of a true multiverse is a quiet, profound concept suggested by several cosmological theories, including the theory of cosmic inflation. The multiverse proposes that our universe is only one of an infinite or vast number of universes, each with its own unique set of physical laws, constants, and initial conditions. This quiet possibility expands the sheer scale of reality far beyond our observable cosmic horizon, suggesting that every possible outcome and combination of existence may be quietly playing out in countless other universes. Fact 70. The quiet existence of dark matter is essential because it provided the gravitational scaffolding for galaxies to form. The gravity of ordinary matter alone was not strong enough to overcome the rapid expansion of the early universe. Dark matter, which makes up about 27% of the mass energy, formed the first large structures, the dark matter halos, which then quietly attracted and collected the visible hydrogen and helium gas to eventually form the stars and galaxies we see today. Facts 71 to 80. Solar System Wonders and Planetary Fate, long-form fact 71. The immense gravity of Jupiter has quietly protected the inner solar system from countless catastrophic impacts over billions of years. As the largest planet, Jupiter acts as a massive cosmic shield, using its powerful gravitational field to deflect or capture numerous comets and asteroids that might otherwise have been sent hurtling toward the Earth. This quiet, continuous gravitational interception is a crucial factor in the long-term stability of the Earth's environment, ensuring that life has had billions of years to evolve without constant, existential interruption. Fact 72. The quiet, faint glow of the extragalactic background light, EBL, which is the sum of all the quiet, cumulative light emitted by every star and galaxy throughout cosmic history, is a powerful measure of the total energy output of the universe. This light, which is extremely diffuse, is so faint that it amounts to only a few photons per cubic meter of space. By analyzing this quiet, ancient glow, astronomers can quietly estimate the total number of stars that have ever formed in the entire observable universe over the past 13.8 billion years. Fact 73. The universe is so sparsely populated that the space between the stars and galaxies is mostly empty, often containing only about 5 protons per cubic meter of space. This quiet, profound emptiness means that the majority of the universe is a deep, cold, and quiet vacuum. Even the space between the planets in our own solar system is far emptier than the best vacuums we can create on Earth, confirming that matter is a quiet, rare, and precious commodity in the cosmic vastness. Fact 74. The universe contains an immense, quiet, and ancient system of comets known as the Oort cloud. This vast, spherical cloud of icy bodies is believed to quietly envelop our entire solar system, extending almost halfway to the nearest star. The Oort cloud is the quiet primordial reservoir for most of the comets we observe. These comets are thought to have been gently perturbed by the gravitational influence of passing stars or molecular clouds, sending them on long, quiet journeys toward the inner solar system. Fact 75. The intense temperature range on Mercury is one of the most extreme contrasts in the solar system. Due to its very slow rotation and lack of a thick atmosphere to distribute heat, the side of the planet facing the Sun can reach a blistering 800 degrees Fahrenheit, 427 degrees Celsius, while the side facing away drops to a frigid negative 280 degrees Fahrenheit, negative 173 degrees Celsius. This quiet, dramatic difference in temperature, nearly 1,100 degrees, is a testament to the quiet, subtle power of a thin atmosphere's inability to retain or circulate heat across the planet's surface. Fact 76. The largest anticyclonic storm in the solar system, Jupiter's Great Red Spot, has been raging quietly for at least 350 years. This immense, persistent storm is a quiet, colossal oval of swirling clouds, often twice the diameter of Earth, and it rotates once every 6 Earth days. The quiet longevity and immense scale of this storm are a testament to the powerful, chaotic dynamics of Jupiter's atmosphere, a quiet, swirling beacon on the largest planet in our system. Fact 77. The universe's fundamental particles are not just matter, they are also magnetic fields and radiation. Space is quietly permeated by these fields and by various forms of radiation, such as light and heat. This quiet presence ensures that every corner of the cosmos is influenced by energy flows, even in the deepest, emptiest voids, confirming that the universe is a unified system of both mass and energy. Fact 78. The quiet principle of Olber's paradox poses a simple yet profound question. Why is the night sky dark? If the universe were infinitely old and infinitely large, and filled with a uniform distribution of stars, every line of sight should eventually end on the surface of a star, making the entire sky brightly luminous. The quiet solution lies in the fact that the universe is not infinitely old, and the light from the most distant stars has not had enough time to reach us. The expansion of the universe also redshifts the light of distant stars to lower, non-visible energies, ensuring that the night remains dark and quiet. Fact 79. The entire universe is quietly governed by the conservation of energy, which states that the total amount of energy in the cosmos remains constant. Energy cannot be created or destroyed, only transformed from one form to another. This quiet, fundamental law ensures that the universe operates on a closed budget of energy, dictating the ultimate fate of all stars, black holes, and galaxies over immense cosmic time. Fact 80. The nearest star to the Sun, Proxima Centauri, is so incredibly distant that driving a car at 70 miles per hour would take more than 356 billion years to reach it. Even traveling at the speed of light, which is the fastest speed possible in the universe, it would take over 4 years. This quiet, immense distance between star systems confirms the profound emptiness of interstellar space and the vast, challenging scale of any potential travel beyond our solar system. Facts 81 to 90. Extreme cosmic speeds and unsolved puzzles. Long-form fact 81. The quiet, extreme speed required for a spacecraft to escape Earth's gravity is more than 25,008 miles per hour, or nearly Mach 33. This precise velocity, known as the escape velocity, is the minimum speed needed to break free of our planet's gravitational pull and quietly embark on a journey into the solar system. This immense speed is a direct measure of the quiet, powerful gravitational bond that holds us to our planetary home. Fact 82. The entire International Space Station, ISS, quietly completes an orbit of the Earth in approximately 90 minutes. This incredible speed allows the astronauts aboard the station to witness a sunrise and a sunset every 90 minutes, providing them with about 16 sunrises and sunsets every 24 hours. This quiet, rapid orbital motion is a constant reminder of the relatively short distance to the edge of space and the immense speed required to maintain a stable low Earth orbit. Fact 83. The quiet, ultimate distance to the entire universe, the part beyond the observable region, is unknown, and it may be literally infinite in extent. Scientists estimate that if the cosmos underwent a rapid, super-fast expansion phase called inflation during its earliest moments, the entire universe could be at least 250 times larger than the observable region. This quiet, potential infinitude means that the visible cosmos is likely just a small, luminous corner of a much vaster, eternal reality. Fact 84. The quiet temperature of Neptune's moon Triton is the coldest known object in the solar system, with an average surface temperature of about -391 degrees Fahrenheit, -235 degrees Celsius. This quiet, profound chill is due to Triton's immense distance from the Sun and its highly reflective surface, which allows very little sunlight to be absorbed. This deep, quiet cold makes Triton a world of frozen nitrogen and ice, a beautiful, frigid landscape at the outer edge of our solar system. Fact 85. The quiet existence of dark matter is not just a theory. It is confirmed by the phenomenon of gravitational lensing, which shows that the total gravitational mass of galaxy clusters is much greater than the visible matter they contain. The dark matter forms the gravitational anchor of these colossal structures, and its quiet, unseen pull dictates the orbits of the galaxies within the cluster. This subtle, persistent gravitational effect is the definitive evidence for the universe's most abundant, yet invisible, constituent. Fact 86. The quiet, scientific interpretation of the term spacetime is that it is a manifold, meaning it appears locally flat near every point, just as the surface of the Earth appears flat at small scales. This quiet geometric property is crucial for understanding how light and objects move through space. The local flatness ensures that, despite the massive warps caused by planets and stars, the quiet laws of physics remain consistent throughout the universe. Fact 87. The universe is filled with colossal, almost perfect vacuums known as voids, which are regions of the cosmic web that are nearly devoid of galaxies and matter. These quiet, immense structures were formed by the initial density fluctuations in the early universe, where the quiet pull of gravity ensured that matter flowed away from these underdense regions and toward the denser filaments and nodes. Fact 88. The most distant star-forming nebula in the Milky Way, W51, is one of the largest and most active star factories in our galaxy. This quiet, luminous cloud of gas and dust has been operating for millions of years, constantly giving birth to massive young stars. These colossal nurseries are a quiet testament to the Milky Way's ongoing quiet cycle of stellar creation, ensuring the continuous birth of new suns in the cosmic expanse. Fact 89. The multiverse theory, which proposes the existence of countless universes, suggests that one of the quiet possibilities is a quantum immortality. This quiet concept, derived from the many worlds interpretation of quantum mechanics, suggests that for every fatal event that happens to you, your consciousness quietly splits into another universe where the event did not happen, leading to an almost eternal, subjective stream of existence. Fact 90. The entire universe, including all stars, galaxies, and life, is a fleeting thing in the lifespan of the cosmos. For nearly 2/3 of the time since the universe began, Earth did not even exist. This quiet, profound perspective reminds us that our planet and our civilization are a relatively recent phenomenon in the vast ancient history of the universe, a brief, luminous moment in the long, quiet march of cosmic time. Facts 91 to 100. Final quiet truths and the edge of knowledge. Long form. Fact 91. The quiet difference between the mass of the Sun and its volume is staggering. While the Sun is roughly 100 times wider than Earth, it would take about 1.3 million Earths to fill the Sun's volume. This quiet discrepancy between volume and linear diameter is a basic principle of three-dimensional geometry, but when applied to the immense scale of stars, it profoundly illustrates the sheer, quiet size of our central star. Fact 92. The existence of a unified theory of everything, TOE, is the quiet, ultimate goal of modern physics. A single theoretical framework that would elegantly describe all fundamental forces and particles in the universe. This theory would quietly merge the immense, gravitational scale of general relativity with the microscopic, bizarre realm of quantum mechanics, resolving conflicts like the nature of the singularity in a black hole. Fact 93. The most distant light we can currently detect, the cosmic microwave background, CMB, radiation, has traveled a co-moving distance of about 45.7 billion light-years to reach us. This immense distance represents the radius of the visible universe at the time the light was emitted. This quiet, vast reach of ancient light is the ultimate evidence of the universe's rapid expansion and its colossal, observable size. The universe is filled with a vast population of helium, the second most abundant element after hydrogen. Helium is primarily created by the fusion of hydrogen atoms in the cores of stars, including our Sun, and this quiet, continuous process is what prevents the stars from collapsing under their own gravity. Fact 95. The quiet distinction between the total universe and the observable universe is profound. The total universe is possibly infinite and without spatial edges, whereas the observable universe is a finite sphere determined by the distance light has traveled since the Big Bang. This quiet geometric difference means that the true size and ultimate structure of the cosmos remain a profound, quiet mystery. Fact 96. The entire universe, in its final, most distant state, is predicted to be a cold, dark, and empty expanse, dictated by the quiet, accelerating force of dark energy. This quiet, inevitable end, known as the Big Freeze, will occur when all stars have burned out and the extreme distances will prevent any light from reaching one structure to another. Fact 97. The universe is quietly governed by the principle of parity, which relates to the symmetry of physical laws under a spatial inversion, mirroring. While the strong and electromagnetic forces obey parity, the weak nuclear force, responsible for radioactive decay, violates parity. This quiet, subtle asymmetry at the most fundamental level of nature is one of the deepest truths of particle physics. Fact 98. The most dense object we can observe, a black hole, is so dense that its gravity can quietly launch surrounding particles to near the speed of light, creating immense, energetic jets from its poles. This quiet, colossal acceleration turns black holes into the most efficient particle accelerators in the entire universe. Fact 99. The entire universe, when measured by the energy density required to flatten its geometry, is equivalent to about 5 protons per cubic meter of space. This quiet, incredibly low density confirms the vast, subtle emptiness of the cosmos, even when including the invisible dark matter and dark energy, and illustrates the quiet, diffuse nature of matter in the universe. Fact 100. The quiet search for the nature of the universe is a journey to the edge of what we can know. Every distant galaxy, every quantum quirk, and every second of time points to a reality that is both more vast and more intricately woven than we can easily comprehend. The quiet truth is that the universe is not just a place we inhabit. It is the ultimate expression of possibility, a constant, gentle invitation to wonder, and the endless horizon of our own quiet curiosity.